Hello, my name is Mandeep Patel. I am a senior studying mechanical engineering at the University of Texas, and this is my solution for autonomous tote tracking and automatic data entry. So, the system as a whole uses sensors, wireless communications, and computer aided data entry software to help reduce the everyday task of entering data. It also provides accurate measurements of the location and weight of each tote. Now, there are a couple key considerations that were made when designing this system that are specific to your route from Michigan to Mexico. So the first is that each trip takes between 2 to 3 months, which means that whatever power cell we're using has to last for the entire cycle of that trip without needing to be changed out. And the second aspect to that is the totes themselves have a lifespan of 15 years, which means that the system would not need any additional modification for that length of life. The second aspect to consider was that this route is overland. Now, there are other systems out there that do allow you to track the location of a shipping container, the weight composition, and what's inside of it. But these systems are incredibly expensive. They take into account that there are different types of objects in each container and that there is a necessity for satellite communications. We recognize that in the tote there's only one material and it's going to be in an area of cellular coverage throughout the entirety of the trip, so we're able to reduce costs by taking into consideration those two factors. And the last aspect of this is the autonomous data entry. So we wanted to remove the manual requirement to enter in data points, and we did this using off-the-shelf software. This has two distinct benefits. First and foremost, off-the-shelf software is already developed, so it reduces the total implementation timeline in terms of its length, so we're able to get this system rolling much faster. It also allows us to reduce costs by not having to develop an entirely new system. Simply licensing it from the company gives us everything we need in order for the system to work. So the system's capacities are broken down into three components. The first is the sensors themselves. The second is the cellular towers that allow us to communicate with the actual home base. And the third is the software that's used to take that data and then enter it into an Excel spreadsheet. So that's how we're going to break up the technology of the system into three different parts. The first is the weight measurement capability. So what you see on screen is a 3D model of one of the totes. I will go ahead and Alt Tab out of this PowerPoint presentation and show you an expanded 3D model, but essentially the technology relies on infrared sensors that are placed on the top of the unit in order to look down at the actual material. The way the weight measurement works is it actually senses how far the material is from the sensor in order to calculate the total height of that particular material. Using the height, we can then determine the total weight if we know the individual weight of the material itself. And so it's kind of a backwards calculation using the height of the material to then determine how much of it is in the container to then calculate how heavy that is. But it is incredibly accurate. This system is actually used in a wide variety of industries, including the oil and gas field. British Petroleum uses a system similar to this. And it's very accurate because an estimate is made or an average is taken of the total heights in that barrel. So if the tote is moving around and the material is moving around because of that, the weight measurement won't be thrown off because what you're getting is an average of the different heights, and that cancels out any anomalies. So anything outside of the median range is automatically canceled out, and the weight is calculated using a median set of data points. So now let's look into actually how it looks in terms of the technology itself. Okay, so this is a live rendering of what the tote would look like with its modification. You'll notice that at the very top, there's a small module that houses everything this barrel uses in terms of its modifications. So that's where the battery packs would go, that's where the IR sensor is, and that's where the antennas are housed as well. There are three key aspects to the system that I want to point out. First is that only one barrel will have a cellular antenna and the rest of them will have a Bluetooth node. We'll talk more about that later in the communications section of this presentation, but that is one aspect. The second aspect is that the bottom of the module is actually covered in glass and the top can be covered with any material. That glass allows the IR sensor to look down and see how much of the material is left. And the third aspect of this modification actually occurs on the bottom of the tote itself. So at the bottom of the tote, you'll notice that there's a hexagonal or octagonal outlet. Now, this is going to be where the material actually leaves the tote. So you can see that this has not been modified in any way whatsoever. So what this allows us to do is it allows us to automate the data entry and data collection without interfering with any of the day-to-day movement of the totes. So in the actual route, I noticed that there were multiple points where third-party workers would be moving the totes off of one method of transportation onto another. What I wanted to avoid for the company was to have you guys have to retrain those third-party workers because of modifications that were being made to the tote. So that is the entirety of the weight collection system, and this is the modifications that would be made. All right, so let's now talk about how the communication system works. So what you'll see is a display of the truck itself containing these totes. You'll notice that a lot of them have the word S on it, and one of them has M. So those are the slave totes. They basically only have Bluetooth communication. What this allows us to do is it allows us to help reduce the cost by removing the total number of cellular antennas we need on each tote. What you'll notice is that the master Bluetooth signal encompasses all of the other slave units, and the slave units have some overlap with each other. What that allows us to do is it allows us to create a network where signals can be sent over Bluetooth until they get to the master signal, and then that master tote can send out data to a cellular network and then get that stuff back to home base. And so really what this system was made to do was to have some overlap just in case, a tote moves slightly out of position or something like that. And it was designed to help reduce the cost of the system by only having one master tote using a cellular signal. So this also reduces the power requirements for the system as a whole. And so what you'll notice is this is a graph of the cellular data coverage in the United States. You'll see that all the way from Michigan to the tip of Texas, you have cellular coverage. And then in Mexico, you also have coverage in a wide variety of areas, including Monterrey and a lot of the other industrial areas. And so lastly, this is a calculation of the cellular D-cell batteries. So what you'll notice is that using 2 D-cell batteries, the slave units actually have a operation capacity of 400 days, and the master unit has an operation capacity of 4 months. So this is a really good system because you're not going to be changing out batteries every single day or every single cycle on every single tote, just on the master totes, and annually you'll change them on all of the slave totes. So the last aspect of this presentation is the automated data entry. So I'll quickly show you a video of how this works. But basically, the sensor nodes are sending data all the time, and there's a software package using Arduino that allows us to directly enter this into Excel. So what you'll notice is you can choose which measurement you want to take account of. So you can choose location or you can choose weight, and you'll notice that that data is automatically logged in. You get both the date, time, and the data entry port. So in this example, we were collecting temperature data, but you could go ahead and do this with any type of data. So that's basically how it would work. And at the end of the day, you'd be left with an Excel sheet with a row of data points, the date and time that they were taken. So that's pretty much everything that I assume you guys would need in terms of data. One other alteration we can make to this is to have a 3D representation or a 2D representation of where the data was taken on a map. And in order to do that, it's not too complicated. The cool thing about Arduino is that you can just use an API, such as Google Maps API, in order to have that data represented on a map itself, instead of just as coordinate numbers. So that pretty much concludes the technology aspect of this. Let's talk about the financials really quickly because I wanted to help reduce costs as much as possible. So what you see on screen is a per part cost of each unit, both for the slave and the master components, for the number of totes, for the 145 totes that you guys have. And calculating in the savings, I didn't really have much to go off of, but I basically based it off of hourly earnings of I think $10, and I just used that to determine the total savings per year. Then I calculated the ROI, and it came out to 2.63 years, which is not too bad, especially considering this does consider a annual, operational cost associated with it, as well as the initial cost for not only the hardware, but also the installation and any software development or retraining that would need work. So this is a very pessimistic analysis of the ROI. And last but not least, I want to go over really quickly a conclusion slide listing all the benefits of the solution. So the first and foremost benefit of this solution is low cost of implementation. So the limited number of modifications, you only need to create one modification on the lid of the tote itself and then seal that again. Means that there's a lower cost for initial installation, and using pre-built software helps further reduce that cost. But in addition to that, you also automate the data entry, so you're able to reduce the amount of unnecessary labor costs. And the second aspect to this is the ease of use. So it does not disrupt current processes of transportation. It will not affect your vendors. It will not affect your buyers. It won't alter your current rate of distribution. And the last thing is that this is a tailor fit technology system. So it was not designed for overseas crates or something like that. This was designed for your specific route. It can be used on other land routes of similar timescales, and it helps basically make sure that this system is going to work how it should, and it's going to work for that period of time that I specified. So that pretty much concludes my presentation. I hope you guys liked it. And if you do have any questions, feel free to email me at this email that is, I guess, presented on screen. And with that, thank you for the opportunity.